All right, now problem number 23 says find the value of x. So looking at this, I have an exterior angle. So I know the angle is equal to 1/2 the difference of these two arcs. So 1/2 of x minus 83. And usually the way I put this, since the x is the furthest away from the angle that I'm looking at, that one's got to go first. So I'm going to take the x minus the 83. Alright, so to solve this, I'm going to multiply everything by 2 so that I can get rid of the fraction, and consequently I get rid of the decimal. So because 2 times 10.5 is going to be 21, so 21 is equal to x minus 83. So to get x, I want to add 83 to both sides. So that tells me that x is going to be 104. Okay, now for number 24, it's the same idea because I have this external angle. So I know that 40 is equal to 1/2 of 115 minus x. Okay, and again, I'm using the 115 first in this case because the 115 is kind of furthest away from the angle that I'm looking at. Okay, so again, I want to multiply everything by 2 so I can get rid of the fraction. Those cancel. 2 times 40 is 80. Is equal to 115 minus x. Now I'm going to subtract the 115 from both sides. That's 0. I have a negative x. Okay, so I want 80 minus 115. That's going to be a negative 35. So technically I'm going to divide by a negative 1 to kind of cancel out the negatives. So that tells me that x is equal to 35 on number 24. All right, on 25, Kn is 4, Jn is 20, Ln is 10, and Mn is x. Okay, now this one, since I have chords that are intersecting, that tells me that the product of each chord is equal to each other. So that tells me 4 times 20 is equal to 10 times x. So 80 is equal to 10x. Divided by 10 tells me that x is going to be 8. I want ml, so I need to substitute the 8 here. So ml is going to be equal to 8 plus 10, which is 18. All right, for number 26, it's the same setup. Basically, because I have the two chords that intersect, this time I just have a lot more x's. So on this one says Kn is x minus 1, Jn is x plus 20, Ln is x plus 11, and Mn is x plus 2. Okay, so I still multiply the different parts, so it was going to be x plus 2 times x plus 11 is equal to x plus 20 times x minus 1. Alright, so I need to FOIL this, so x times x is x squared, x times 11 is 11x, 2 times x is 2x, and then 2 times 11 is 22. On the other side, I'm going to have x times x again, so that's x squared. X times a minus 1 is negative x. 20 times x is 20x. 20 times a minus 1 or negative 1 is a negative 20. Combine like terms on each side, I get x squared plus 13x plus 22 is equal to x squared plus 19x minus 20. Now here I can subtract x squared from both sides. That goes to 0. I'm also going to subtract the 13x on both sides. That goes to 0. So I'm left with 22 is equal to 6x minus 20. If I add 20 to both sides, that tells me that 6x is equal to 42. Dividing by 6 tells me x is 7. Alright, for number 27, to find the value of x, it's going to be 6 times the whole length, so it's really 10 plus 6, okay, is going to equal to 8 times the whole segment RT, so that's going to be x plus 8. Here I can simplify, that's going to be 6 times 16 is equal to, if I distribute, that's going to give me 8x plus 64. 6 times 16 is going to come out to be 96. So here I have 96 is equal to 8x plus 64. I subtract 64 from both sides. I get 32 is equal to 8x. Divide by 8 is going to give me that x is equal to 4. Number 28 says a park downtown has a circular fountain with a walkway that runs tangent to the fountain. You want to find the radius of the fountain using indirect measurement. You stand on the walkway at a point 16 meters, so that's what this CB is, from where it meets the fountain. This point is represented by C in the diagram below and is 9 meters from the edge of the fountain. So that's this piece right here, this CE. Knowing CB is tangent to the circle, find the radius of the fountain. Alright, so since this is tangent to CB, it's going to be 16 squared is equal to 9 times all of CD. So CE is 2R. Then I have to add the 9 to get this entire length here. I'm going to rewrite this as 2R plus 9. I just switched it. Instead of having 9 plus 2R, I have 2R plus 9. Same idea. Then 16 squared is 256. I'm going to have to distribute the 9 to both of these, so that's going to give me 18R plus 81. If I subtract 81 to both sides, let's see, 256 minus 81 is 175. Now I need to divide by 18 on both sides to get my radius. And that comes out to be a radius of 9.7 meters. Okay, now for number 29, it says write the standard equation of the circle shown below. Alright, so what I need to do is I need to find the center. Remember that the equation for a circle is x minus h squared plus y minus k squared is equal to my radius squared. Alright, so what I'm going to do here is I'm going to look at finding my center of the circle. So it looks like I have this point right here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 10. So that means I need to count 5. So I have this point here. And just to make sure I'm counting right, I'm going to count this way, vertically. So 2, 3, 4, 5, 6. Yes, so that's 10. So 5 and 5 each way. So that tells me my center is here. So that's going to be at -2 and then -1. Okay, so I know that I have x minus a -2 squared plus y minus a -1 squared is equal to my radius squared. So if I count, my radius was 5, so it's 5 squared. Since I'm minusing a negative, that's going to become x plus 2 squared plus, same thing here, I'm subtracting a negative, so it's going to be y plus 1 squared. And 5 squared is 25. So this would be my equation in standard form for a circle.